Hi everyone, my name is Richard Vogt, and today I will be going through my ENPM 691 final project. It is the investigation, exploitation, and remediation of a vulnerable web server. To start us off, I went through the agenda and talked about how we'll go through the investigation, exploitation, remediation, and then a quick demonstration. The goal of my project was to investigate the vulnerabilities of the textbook-contained web server Tiny.c using my VM as well as a Raspberry Pi, and then attempt to patch the vulnerabilities while maintaining the core functionality of the program. Tiny.c is a simple sample website that is included in the textbook Computer Systems, A Programmer's Perspective, 2nd edition, on page 919. It's a very simple web server that's written in C that serves both static and dynamic content via GET. It's a very simple, basic web server. It's only about 250 lines of code. It does not support any modern things. It doesn't have any JavaScript. It has no SQL database, no Mongo database. There's no login. There's no passwords. There's no room for all the standard things that you would expect to be able to exploit out of a web server. This brings me to my investigation. The first thing I did was obtain the source code. I downloaded it off the web, built and run it, went to my Firefox browser, and found this. When I was running it through my VM, I had to use localhost. When I was running from my host machine, connecting to my VM, I used the IP address of the VM. Static content is all contained within the main directory, and dynamic content is under CGI-bin. Over here we can see what the standard website looks like, where it has Dave O'Halloran's name and a picture of Godzilla. And here we can see an example of the dynamic content, this program called Adder, which takes two integers and adds them together. Now I'd like to go over some of the investigation methods that I did. Like any attacker, I hit the website with a large number of A's. I tried to dump shellcode into the URL. I tried large numbers. I tried negative numbers. I tried bash commands, Python scripts, Perl scripts. I tried to move around in the directory. I even tried to write a Python brute forcer to dump different characters in there and just see what happens. Basically all the different things that I could think of, including even looking at the source code and even looking at the compiled source code using a decompiler using GDB just to see what I could find. Over the course of this project, it was a lot of trial and error, and this was a page that I came accustomed to, or even sometimes just crashing the website entirely itself. Especially when I made the Python brute forcer, that brought it down time and time again. When I wasn't doing that and I was manually poking and prodding, this was one of the most common things I saw. I'd like to go into the exploitation of denial of service. There was three main ways that I was able to do this. The first of which was overflowing the buffer of the URL by just dumping a large number of A's into it. A little more complicated was writing a Python script to continuously hit the web server until it crashed. And if you're a script kiddie, you can just use something like low Earth orbit ion cannon to bring the site down. And you will get this unable to connect, and you will wonder what happened. The second exploit that I was able to uncover was the unrestricted file access that Tiny.c gives a user. When you navigate to the website, it's designed to only give out 4 different kinds of content, that being HTML, text, JPEGs, and GIFs. In the source code, when a user actually enters the name of a file that is not one of the 4, it defaults it to being a text file. So this leads to unforeseen consequences and leaves the program vulnerable to attack. An attacker can get the compiled source code, the makefile, or even the actual source code itself. Here we can see an example of this where the user is able to access the README file. Here we can see the user accessing the compiled source code. And here we can see the source code itself being accessed from the website. The third attack that I was able to discover was integer overflows. Tiny.c takes the value of the strings found in the URL, writes them to an environment variable, and then passes them to the adder function. Integers in C are only 32 bits, and in C it's undefined behavior when you have integer overflow. So if you take two numbers like 2 to the 32nd and 2 to the 32nd and add them together, some of the behavior is undefined. As we can see here, these two large numbers added together equal -2. This isn't something that you want to happen in your program, especially on a web server. It's better if you do something about this. And this brings me to the remediation. After identifying potential vulnerabilities, I wanted to see how I could patch them while maintaining all of the core functionality of Tiny.c. This included main themes like input sanitization, checking the string lengths, and checking the return value of different functions. The first remediation I did was on the unrestricted file access. I limited it so that the users could only access the 4 kinds of files: HTML, text, GIFs, and JPEGs. In the original state, it would treat any file that's not one of these 4 as a text file and give the user access to it. I also canonicalized the file name and checked that the user is in the correct directory or correct subdirectory. This would help to prevent the user from accessing areas outside of tiny.c and gaining access to things like a password file or root directories or anything else like that. The next remediation that I was able to do was remediating the integer overflows. When the program runs dynamic content, it passes the user input to an environment variable called queryString, which then it extracts the numbers from. I verified the size of the numbers that it was inputting to make sure that they would not overflow. In addition, I made a quick modification so that way the user who is running the program is only able to enter valid port numbers, those being numbers between 0 and 2 to the 16th. I made sure that all user input is checked, and I checked the length of various strings all along the way that I could. I was also able to remediate one of the 3 denial of service attacks that I discovered. I found that after dumping about 8,050 A's in the program, it tended to crash consistently. So the simple solution was to cut off any excess values added into the buffer. I also went through some general improvements across the entire program, such as transitioning from strcpy to strncpy where possible to limit the attack surface. As we've seen throughout this class, that having strcpy allows an attacker to put a payload onto a C program. I kept ASLR enabled. I ran a static code analyzer, CPP checker, and fixed any undefined behavior. This included sprintf with the buffer as a source and a destination. It pointed out some integer overflows, and it also pointed out access to a buffer outside of its allocated memory. I added -w error to force any warnings to become errors to keep the source code from compiling unless all the warnings were fixed. I attempted to fortify the source code in the make command, but found that it was already included. In addition, I used Valgrind to check for memory leaks and found none. Some of the future endeavors that I would like to do some better remediation of the denial of service attacks that I was able to conduct. I'd like to exploit this more with directory traversal. I'd like to see if I could move around the directory better, gain access to more files. I'd also like to develop an exploit based on integer overflows. I'd like to develop an exploit based on writing to the environment variables. And of course, as always, popping shells would be more fun. Now we'll go through the live demonstration. Here we have the original version of tiny.c, and as you can see, it's running on my Raspberry Pi. We're now going to try to access a file, such as the source code, which it allows, as well as the compiled program itself. And now we're going to go to the secured version, which we can see here is running on my virtual machine. We will now attempt to access the secure version. And as you can see, it's forbidden, as well as the compiled binary. Here we have the vulnerable version of the website, and we're going to go to cgi-bin/adder. And here we can see, when adding to the program, numbers under the maximum value work fine. But when they go too high, we get undefined behavior. Here you can see it is running on my Raspberry Pi. And now we're going to show this on the secured version. We'll start out by having some behavior that is allowed. And now we're going to overflow the integers. And as you can see, the values revert to 0. Here you can see it's running on the VM. Here we have the vulnerable version of tiny.c running on my Raspberry Pi. And now we're going to attempt to overflow the URLs buffer. by dumping in 16,000 A's. As you can see, this file was not found, and the website crashed with the segmentation fault. I'm going to attempt the denial of service attack on the improved version of Tiny.c. Here we can see it's running on the virtual machine. I will now dump 16,000 A's into the buffer. As we can see, this is not found. And thankfully, the machine is still alive. Overall, this was a very fun course and I learned a lot, but this project really helped teach me a lot about secure coding. The first thing that I realized that in a modern world, when you're developing a web server, you might not want to necessarily use C. When there's other things out there, you might want to go with a language that's designed for the web. There's plenty of APIs, and there's plenty of people using these and hammering them out and removing any vulnerabilities that exist. I also learned that you always want to sanitize your user input. This is very important because the users might not necessarily know what they're doing. It could just be a user that doesn't understand how to use your program, and they might inadvertently crash it. I learned to always look at what the compiler is telling you. Oftentimes when I was coding my way into a hole trying to patch a different vulnerability, the compiler would fail and give me a bunch of different warnings. Always try to keep it simple. Whenever you're trying to fix something or patch a vulnerability, adding a whole lot of code might not actually do you a whole lot of good. It might actually introduce more vulnerabilities. I also learned that you always want to default to deny, so if a user wants to access something, unless you explicitly want to give it to them, you should probably deny it. I also learned that you might want to avoid the use of deprecated methods. By definition, deprecated methods are unsafe to use. Just overall, this stuff is actually very difficult to do. On a seemingly small program, getting an exploit to work is quite difficult, and having more team members on the team might have helped me get further in my goals. Here are my sources, and here's my contact.